If you've ever seen a coral reef, either in real life or through one of those dreamy underwater documentaries, you might have been struck by how colourful, chaotic and alive it seems. Fish darting like confetti, sea anemones swaying like slow-motion dancers, and the whole thing bathed in sunlight that flickers like a disco ball on the seafloor. But there's one part of this vibrant party that often gets overlooked: the coral itself, that lumpy, stony stuff. You might be surprised to learn it's very much alive, and even more surprisingly, it's an animal, a rather peculiar one. So what exactly is a coral? It's not a plant, though it kind of looks like one. It's not a rock, even though it builds things that resemble underwater stone castles. And it's not a single creature, but rather a massive community, like an apartment building where every unit is occupied by a clone of the same tenant. Let's start at the smallest scale. A coral is made up of tiny individual animals called polyps. Each polyp is kind of like a miniature sea anemone, with a soft, tubular body and a ring of tentacles around its mouth. These tentacles are equipped with stinging cells, yes, the same type used by jellyfish, called nematocysts. They are used to capture microscopic food from the water. So far, very respectable animal behaviour. But here's where it gets clever. Each polyp builds itself a little limestone cup to sit in, made from calcium carbonate, the same stuff you'd find in seashells or chalk. When thousands or even millions of these polyps live together and keep building on top of one another over years, decades, even centuries, you get what we know as a coral reef. Slowly, patiently, polyp by polyp, they raise enormous underwater fortresses. Now, coral polyps are quite self-sufficient, but they're not working alone. Inside their tissues, they host tiny microscopic algae called zooxanthellae. These little algae are like the in-house chefs of the coral world. They perform photosynthesis, converting sunlight into energy, and share the nutrients with their coral landlords. In exchange, they get a cozy place to live and access to the coral's waste products, which are basically a gourmet meal for a plant. It's a beautiful bit of symbiosis. One provides shelter and nutrients, the other provides energy and colour. In fact, those brilliant hues that make coral reefs look like underwater rainbows, that's mostly the algae. Without them, the coral is pale, almost ghostly, what we call bleached, and we'll get to that later. But for now, imagine this quiet, ancient partnership where light feeds algae, algae feed coral, and coral builds homes for countless others, all under the sun-dappled surface of the sea. But let's not forget the coral's lifestyle. Despite their stationary appearance, polyps are surprisingly active at night. Once the sun sets and the reef calms down, they extend their tentacles to catch plankton and other floating bits of food. It's their midnight snack time, quiet and methodical. During the day, they tuck their tentacles back in, like pulling down the blinds, and let the sun feed their algae instead. Corals reproduce too, both sexually and asexually. Some polyps just clone themselves, budding off little duplicates to expand the colony. Others save up for a grand, synchronized spectacle. Once a year, during a particular phase of the moon, many coral species release their eggs and sperm into the water all at once in a dazzling underwater snowstorm. The goal? Maximize the odds of fertilization while overwhelming any hungry mouths nearby. It's one of the ocean's most magical events, and no one's quite sure how they all agree on the timing. Moonlight? Temperature? Vibes? Maybe all three? And if you're wondering how coral knows where to grow, it turns out they're pretty picky about location. They like warm, shallow, clear water, tropical seas where sunlight can reach them and algae can thrive. Too hot or too murky, and they start to struggle. Most reefs form within the tropics, hugging the equator like a living necklace. Now, while we often talk about coral like it's one thing, there are actually hundreds of species. Some grow in branching formations that resemble antlers or fingers. Others are more like brainy boulders, with convoluted folds and a slow, methodical growth pattern. Some are soft corals, like sea fans and whips, which don't build hard skeletons but still contribute to the complex reef environment. And not all corals live in shallow waters. There are deep-sea corals that grow in the dark, cold depths of the ocean, far from sunlight. These ones don't bother with algae at all. Instead, they feed entirely on drifting plankton. Some of these deep-sea coral colonies are ancient, literally thousands of years old, and grow so slowly you'd barely notice a difference in your lifetime, which to them probably seems like a blink. All in all, corals are marvels of quiet engineering. They don't chase prey, they don't move around, and they don't make much noise, but through patience, persistence, and cooperation, they've created some of the most complex and important ecosystems on the planet. It's easy to overlook them, perhaps because they don't shout for attention, but their genius lies in that very stillness. If you think about it, there's something wonderfully comforting about that. The idea that something so essential, so vibrant, so life-giving can also be so serene and slow. It reminds us that speed isn't everything, and that sometimes the world's most brilliant architects wear soft bodies and build with nothing but time, sunlight, and trust. So next time you picture a coral reef, try not to think of it as just colourful background for fish. Think of it as a sprawling city built by microscopic tenants, powered by sunlight and humming with quiet intelligence. An ecosystem of introverts, you might say, building empires, one tiny limestone apartment at a time. Coral reefs may look like natural chaos, twisting, sprawling, colourful tangles of marine life, but they are in fact some of the most carefully constructed environments on the planet. And the architects behind them? Well, they're about the size of a grain of rice and don't even have a backbone. Yet over time, these tiny coral polyps have built enormous structures visible from space. Not bad for creatures without thumbs, or even brains. To understand how reefs are built, we need to look at the raw materials. Coral polyps, as we've learned, create a hard external skeleton made of calcium carbonate, essentially underwater limestone. This skeletal structure acts as both a home and a foundation. As each polyp grows and dies, it leaves its little limestone cup behind, and new polyps build on top of it. Layer by layer, generation after generation, the reef slowly rises, and when we say slowly, we really do mean slowly. Most reef-building corals grow at a rate of about 1 to 10 centimeters per year. That's roughly the height of a Lego brick. So imagine stacking one Lego each year for hundreds, even thousands of years, and you start to appreciate just how long it takes to form even a modest reef. Over time, as more corals grow and die and grow again, the structure becomes more complex. Some species build upward, like high-rises, while others spread out in wide, plate-like formations. There are corals that form branches, domes, ridges, and shelves, each contributing a unique architectural style to the overall design. It's like an oceanic cityscape with different neighbourhoods and zoning regulations depending on light, current, and depth. There are actually several types of coral reefs, each shaped by geological and biological factors. The simplest is the fringing reef, which grows directly along the shoreline. Then there are barrier reefs, which form farther offshore and are separated from land by a lagoon, Australia's Great Barrier Reef being the most famous example. And then there are atolls, which are ring-shaped reefs that form around sunken volcanic islands. Picture a donut floating in the ocean, made entirely of living rock and teeming with marine life. At the heart of these structures is a remarkable process of cooperation, not just among the corals themselves, but with the surrounding environment. The reef is perfectly positioned to take advantage of the sun, the tide spare, and the gentle flow of nutrient-rich water. Corals tend to grow facing the prevailing currents, allowing them to filter more food and oxygen from the water. They also need sunlight to feed their resident algae, which means the top of the reef tends to grow closest to the surface. But this presents a challenge. The reef must grow upward to reach the light, but if it gets too high, it risks being exposed at low tide, which could kill the corals. So the reef adjusts its growth rate naturally, maintaining a delicate balance between rising sea levels and staying submerged. It's like a living skyscraper that automatically adds or subtracts floors to avoid flooding, or in this case drying out. Interestingly, the reef's structure also affects its environment in return. As it grows, it creates complex habitats, shelves, tunnels, nooks and crevices that become homes for a dazzling variety of marine species. Fish use the reef as a nursery, a shelter, and a hunting ground. Crustaceans hide in its cracks. Sponges and sea fans attach themselves to the coral's surface. And sea turtles stop by like they're checking into a well-loved hotel. The reef even shapes the water itself. As waves crash against the reef's outer edge, the energy is dissipated, protecting coastlines from erosion. Reefs act as natural breakwaters, calming storm surges and giving mangroves and seagrass beds the peace they need to thrive. In a very literal sense, coral reefs protect the shore. Not bad for a wall made by jellybean-sized animals, but for all their resilience, reefs are also vulnerable. Because coral is made of calcium carbonate, it's very sensitive to changes in water chemistry. Ocean acidification caused by the absorption of excess atmospheric CO2 makes it harder for corals to form their skeletons. It's like trying to build a house with soggy bricks. Add in pollution, warming seas, and human interference, and the reef's construction schedule starts to get seriously behind. Despite these challenges, reefs remain some of the most impressive and enduring structures on Earth. The Great Barrier Reef alone stretches over 200-300 kilometres along the Australian coast. That's longer than the distance from Paris to Rome, and it's all alive, or mostly alive at least. Some parts are centuries old, while others are still under construction, as young coral colonies slowly extend the reef's reach. And the thing is, coral polyps don't seem rushed. There's no frantic bustle, no panicked deadlines. They just keep growing millimetre by millimetre, patiently sculpting the seafloor with quiet determination. If coral had a motto, it might be, "Slow and steady builds the reef." And while it may not be fast, it's effective. These reefs are not only beautiful, they're durable. Coral structures can withstand crashing waves, violent storms, and even tectonic shifts, all while serving as the foundation for entire ecosystems. What's even more remarkable is how the reef builds itself in response to its surroundings. It's not like a human blueprint with a set of rigid instructions. It's a living, adaptive process. As conditions change, light levels, water flow, sediment, the coral responds. It shifts growth patterns, favours some structures over others, even allows different coral species to take over if they're better suited to the new conditions. In this way, the reef is not a static monument. It's an evolving organic city. And like any good city, it has its own rhythm. A day on the reef starts with the rising sun, when photosynthetic algae kick into gear and corals retreat their tentacles. Fish begin to stir, darting out of their rocky bunkers. As the day goes on, the reef pulses with life, bright with activity and colour. At night, the scene changes. The daytime residents retreat and the nocturnal creatures emerge. Coral polyps extend their tentacles. Bioluminescent plankton glows softly in the dark. It's an entirely different world, just a few hours apart. All of it made possible by creatures that don't move, don't speak, and don't sleep. Just build. Quietly, persistently, with no reward but the continuation of their kind, and the thriving of thousands of others who call the reef home. So the next time you see a reef, think of it not as a pretty backdrop, but as an epic construction site millions of years in the making. No bulldozers, no cranes, just patience, cooperation, and a little sunlight. Life on a coral reef is anything but lonely. In fact, if coral polyps are the architects, then the reef itself is the bustling metropolis they've built, one that teems with citizens of every shape, size, and colour. You could call it the ocean's version of a high-rise apartment block, shopping mall, food court, and playground all rolled into one. And just like any lively city, it's full of strange characters, complicated relationships, and more drama than a telenovela starring fish with excellent camouflage. Despite covering less than 1% of the ocean floor, coral reefs are home to roughly 25% of all marine life. That's millions of species, from vibrant reef fish and crusty old crabs to squishy sea cucumbers and sophisticated octopuses. It's one of the most biodiverse ecosystems on the planet, and it all starts with the coral. Because reefs are made of calcium carbonate, they form nooks, crannies, ledges, and tunnels that provide perfect hiding places. Every crevice is a potential home, every overhang a shady retreat. Tiny gobies make their homes in burrows, darting out for snacks. Moray eels peer menacingly from rocky hollows. Schools of fish swirl in synchronized patterns above the reef like murmuring birds. It's as if someone took all the most vibrant pieces from 1,000 different puzzles and made them live together in perfect noisy harmony. Let's meet a few residents of this underwater neighbourhood. First up, the clownfish. These orange and white striped charmers are famous thanks to a certain animated film, but their real-life story is even more interesting. Clownfish have a close, almost exclusive relationship with sea anemones, those swaying tentacled creatures that resemble psychedelic pom-poms. While most fish avoid anemones because of their stinging cells, clownfish are immune, thanks to a protective mucus coating on their skin. In return for safety and shelter, they chase off predators and parasites from their anemone host. It's a textbook case of mutualism, two species helping each other out. Or, depending on your perspective, rent paid in pest control. Then there's the cleaner wrasser, small fast fish that set up little cleaning stations on the reef. Larger fish come by and hover, opening their mouths and gill flaps, and the wrasser dart in to pick off parasites and dead skin. It's like an underwater spa appointment. Even top predators like groupers and barracudas submit peacefully, letting the wrasser do their work. No biting, no fuss. just a gentle grooming session in the middle of the sea. Of course, not all relationships on the reef are so polite. The mantis shrimp, for example, is the reef's misunderstood assassin. With eyes that can see polarized light and 16 color receptors, humans have only 3, they perceive the world in psychedelic detail. But their most famous feature is their strike. Some species of mantis shrimp can punch with the force of a bullet, fast enough to create tiny cavitation bubbles that collapse with a flash of light and heat. They use this ability to smash open snails, crabs, and even aquarium glass. And yet, they're only a few inches long. Basically, if the reef had an Olympic boxing team, the mantis shrimp would be banned for excessive enthusiasm. Camouflage is a common strategy here. The reef is a competitive place, and many creatures survive by staying invisible. Stonefish, for instance, resemble algae-covered rocks so convincingly you'd only spot them by stepping on them, which is unfortunately a painful mistake, since they are among the most venomous fish in the sea. Leafy scorpionfish float like debris, blending into seaweed. Even octopuses can mimic the texture and colour of coral to avoid detection. Some species take it even further. The mimic octopus can impersonate flounders, sea snakes, and lionfish, depending on who it's trying to scare off. The reef is full of liars, it seems, but creative ones. There's a clear hierarchy too, with predator-prey relationships that keep the system in balance. Reef sharks patrol the outer edges, snapping up the injured or unwary. Groupers hide in ambush, using their massive mouths to vacuum up smaller fish. At the other end of the spectrum, you have filter feeders like feather duster worms and sponges, which calmly strain particles from the water. There's something for every niche: hunters, grazers, recyclers, and janitors. Parrotfish, for instance, are like the reef's lawnmowers. They graze on algae that grows over coral, keeping it in check so the reef doesn't get smothered. As they chew through the coral surface with their beak-like teeth, they grind up calcium carbonate and excrete it as sand. Yes, that soft white beach sand you sink your toes into on a tropical holiday? It's probably been through the digestive system of a parrotfish. Nature has a funny way of creating beauty through unexpected channels. Crustaceans too play their part. Tiny shrimp work as cleaners, while crabs lurk in the shadows, scavenging anything edible. Some even adorn themselves with bits of sponge or algae for camouflage, like walking fashion statements. Sea urchins prowl the reef floor at night, scraping algae off rocks with their specialized teeth. Yes, they have teeth, and they're called Aristotle's lanterns. Fancy. Not all residents stay put. Sea turtles drift in from the open ocean to feed on sponges, while eagle rays swoop gracefully across the reef in search of buried mollusks. Dolphins occasionally pass through, though they tend to stick to deeper waters. The reef is a crossroads as much as it is the home, offering shelter, food, and rest for a variety of travellers. Even worms get in on the action. Christmas tree worms, named for their spiralled, festive-looking protrusions, anchor themselves into coral and extend their feathery appendages to filter food from the water. If startled, they retract instantly into their burrows like holiday decorations, suddenly remembering they have stage fright. And amidst all this life, death plays a role too. When fish die, their bodies are quickly consumed or decomposed, recycled into nutrients for the reef. Coral larvae settle on the bones of previous generations, predators thin the weak, and scavengers clean the leftovers. It's a remarkably efficient system, no waste, no excess, just a continuous cycle of energy passing from one form to the next. That's the genius of the coral reef. It's not just a habitat, it's a machine. A living, breathing, self-regulating engine of life. Every species is connected, directly or indirectly, through an invisible web of interactions. And somehow it all works, mostly, until something throws it off balance. But let's not worry about that now. For the moment, picture the reef as it is in its prime. A technicolor labyrinth of life with thousands of species bustling about their daily routines. From tiny plankton drifting in the currents to wise old groupers watching from the shadows, everyone has a role to play. It's loud, it's messy, it's dazzling. And beneath it all, those quiet corals keep building the city they started centuries ago. There's something comforting about that. The idea that beneath the surface, far from traffic and inboxes and to-do lists, there's a whole world humming along just fine. A place where fish get facials, shrimp wear disguises, and sand comes from fish poop. Nature, it seems, is not only brilliant, it has a sense of humour too. If coral reefs are cities, then communication is everywhere. You just have to know where to look. Unlike human cities where information buzzes through text, sirens, shouting, and the occasional enthusiastic street musician, reefs tend to be quieter, at least to our ears. But beneath the still surface of the ocean, there is a different kind of conversation going on. The reef may not shout, but it speaks through light, colour, chemistry, and even synchronized events that span miles of coastline. Coral communication and behaviour, though subtle, are astonishingly sophisticated for creatures without eyes, ears, or a central nervous system. Let's begin with one of the most dramatic displays of reef behaviour: mass coral spawning. Once a year after sunset, when the moon is just right, usually a few nights after a full moon in late spring or early summer, reef-building corals across vast areas release their eggs and sperm into the water in a synchronized burst. It's like an underwater snow globe of glittering pink and white spheres drifting upward through the warm night sea. Entire reef systems seem to join in, regardless of species. Some scientists believe that water temperature, lunar cycles, and day length all play a part in timing this event, though no one knows for sure how these simple organisms coordinate such a complex calendar. It's one of nature's greatest mysteries, and a stunning example of community behaviour. This synchronized spawning increases the chances of fertilization in the vast ocean, but it's also a great way to overwhelm predators. Many reef animals, from fish to worms, are only too happy to feast on coral eggs. But when the entire reef releases its reproductive material at once, there's simply too much food for predators to eat it all. The rest floats off to start new coral colonies, carrying the genetic hopes of the reef on warm currents. Communication also happens on a chemical level. Corals, like many marine creatures, use chemical cues to respond to their environment. If a coral is injured, say by a grazing fish or physical disturbance, it releases certain chemicals into the water that nearby corals and even fish can detect. Some neighbouring corals respond by increasing their defences, while others might temporarily retract their feeding tentacles or slow their growth. It's a bit like someone yelling "ow" and everyone nearby flinching in sympathy. Chemical signals also help young coral larvae find suitable places to settle. After their brief life as free-floating plankton, coral larvae drift through the water looking for somewhere to call home. They're drawn to surfaces with just the right combination of light, current, and chemical signature, especially areas where certain types of crusty red algae grow, which often signal a healthy, stable spot for a coral to grow. When they find that Goldilocks zone, they anchor themselves down and begin their slow transformation into a new polyp, eventually joining a colony or starting one from scratch. It's the coral version of browsing the neighbourhood before buying a house. Behaviourally, corals might seem passive at first glance, but they are far from inactive. Most corals are nocturnal feeders, and their daily rhythms are guided by light. During the day, many corals keep their tentacles retracted, relying on their symbiotic algae for nutrients. As evening falls and the light fades, they extend their tentacles into the current to snatch up passing plankton and organic matter. Under the glow of the moonlight or bioluminescence, a reef can seem to shimmer with life as thousands of tiny mouths reach into the dark, like a forest of translucent fingers. And speaking of bioluminescence, some reef dwellers really take things to the next level. While most corals don't glow on their own, many reef species do, including plankton, jellyfish, and certain types of algae. In some tropical reefs, especially in shallow lagoons, you can see bioluminescent sparkles in the water as you move through it at night. Each flicker is a microscopic protest, a flash of light released by tiny organisms in response to movement or disturbance. It's both beautiful and functional, a defense mechanism meant to confuse predators or attract even the bigger predators to scare off the first one. Essentially, if you eat me, you'll glow and get eaten by someone even bigger. Beyond light and chemicals, reef organisms also communicate through sound and vibration. That might sound surprising, but it's true. The reef is alive with noise. If you were to submerge a hydrophone, an underwater microphone, you'd hear a constant crackle like a campfire. This comes mostly from snapping shrimp, which generate loud pops with their specialized claws by creating tiny cavitation bubbles. The noise stuns prey and also helps them claim territory. Fish too make sounds, grunts, chirps, croaks, mostly for mating or warning others to stay away. Some species of damselfish are even known to growl when defending their patch of algae. While coral polyps themselves don't vocalize, they do respond to vibration and water flow. Some researchers believe corals can detect subtle changes in water motion and use this information to guide their feeding or growth. For instance, in areas with stronger currents, corals might develop broader, flatter structures to better catch food, while in calmer waters, more branching shapes are favoured. It's a kind of passive responsiveness, like leaning toward the sun, only underwater. Corals also have a surprising ability to fight, or at least defend their turf. In areas where different coral colonies meet, you'll sometimes find battle lines marked by scars or dead zones. Corals can sting each other with specialised cells called mesenterial filaments, which they extend from their stomach to digest the tissue of their rivals. It's not fast-paced combat, but it's effective over time. Some species also grow faster and simply outcompete others by shading them or blocking water flow. Territorial disputes, it seems, are alive and well on the reef, even if they unfold over months instead of minutes. And yet, there's an undercurrent of cooperation too. Different species of coral often grow side by side, and the overall architecture of the reef is shaped by their combined efforts. Some fish even encourage coral growth. Parrotfish, for example, graze on algae that would otherwise smother the reef, helping keep things clean. Other animals like sea cucumbers and burrowing shrimp aerate the reef floor, keeping sediment from building up. Even though competition exists, the whole system leans toward balance. Perhaps one of the most poetic aspects of coral behaviour is their patience. In a world that often celebrates speed and noise, corals succeed by doing the opposite. They grow slowly, they respond calmly, they change gradually. Their entire existence is built on minute, almost imperceptible adjustments, growing a little more here, retreating slightly there, and yet over time they shape entire coastlines. Their quiet communication is a reminder that intelligence and complexity don't always look the way we expect. You don't need a brain to respond to your environment or to interact with your neighbours. You don't need a voice to say, I'm here, I'm thriving, I'm building something that matters. So while a coral reef may not chatter in the way we do, it's anything but silent. It's full of messages, signals, reactions and rhythms, a symphony in slow motion, a conversation that spans generations. And if we learn how to listen even a little, we might just hear the reef whisper back. Coral reefs, for all their brilliance and biodiversity, exist in a precarious balance. They are masters of stillness, architects of calm, yet they are vulnerable in ways that make their strength seem almost paradoxical. These ancient structures, some of which have been around for tens of thousands of years, now face threats that are faster, larger and more complex than ever before in their evolutionary history. And it all begins with temperature, acidity, and a certain misplaced fondness humans have for carbon. Let's start with the sun, because in the coral world, sunlight is more than just a pleasant backdrop. It's life. Coral polyps depend on their tiny resident algae, those industrious little zooxanthellae, to perform photosynthesis. In return, the coral gets most of its energy needs met. It's a cosy relationship, but one built on precision. The algae need just the right conditions, stable temperatures, clean water, and a comfortable level of sunlight. When these conditions are thrown off even slightly, the entire partnership begins to fall apart. This brings us to coral bleaching. It's a term you've probably heard, but what does it actually mean? In simple terms, when the water gets too warm, the coral becomes stressed and expels its zooxanthellae. Without their colourful symbiotic partners, the coral turns ghostly white, hence the term bleaching. Now, the coral isn't dead at this stage, but it's essentially unemployed, hungry, and extremely vulnerable. If conditions improve quickly enough, the coral can regain its algae and recover. But if the stress continues, if the water stays too warm, too polluted, too unstable, then the coral starves and dies. Temperature changes of just 1 or 2 degrees Celsius, if sustained, are enough to trigger widespread bleaching events. And that's exactly what's happening. Global warming, driven by the increase in greenhouse gases like carbon dioxide, is steadily heating the ocean. In fact, over 90% of the excess heat trapped by these gases has been absorbed by the sea. The oceans are Earth's thermal sponge, but even sponges have their limits. Mass bleaching events have become increasingly frequent and severe over the past few decades. The Great Barrier Reef, arguably the most famous and most expansive reef system on Earth, has experienced multiple bleaching events in just the last 10 years. Some reefs have rebounded in parts, others have not. It's like watching a delicate symphony lose its instruments one section at a time. But warmth isn't the only problem. Our oceans are also becoming more acidic. When carbon dioxide dissolves in seawater, it forms carbonic acid. This lowers the pH of the water and reduces the availability of carbonate ions, the very building blocks corals use to construct their calcium carbonate skeletons. So not only are they being cooked, but their bricks are also dissolving. It's hard to build a house when your concrete won't set. Ocean acidification also affects other reef dwellers, shellfish, sea urchins, and many types of plankton that rely on calcium carbonate to make their shells and exoskeletons. A less visible impact, but no less serious. It's like the foundation of an underwater society slowly eroding molecule by molecule. Pollution adds another layer of stress. Runoff from agriculture and cities carries nutrients like nitrogen and phosphorus into the ocean. You might think nutrients are a good thing. After all, who doesn't want a little extra food? But for reefs, too many nutrients can be dangerous. They fuel the growth of algae that smother coral, cloud the water, and block out the sunlight that corals so desperately need. It's like over-fertilizing a garden until it chokes. Then there's sediment. When forests are cleared or coastlines developed, loose soil gets washed into the ocean. This sediment can settle on corals, blocking sunlight and suffocating the polyps. And because coral reefs thrive in clear, shallow waters, murkiness is no small inconvenience. It's a slow-motion disaster. And let's not forget sunscreen. Yes, your humble bottle of SPF 30 can be a problem too. Certain chemicals commonly found in sunscreens, like oxybenzone and octinoxate, can be toxic to coral larvae, disrupt growth, and contribute to bleaching. The amounts are small, but in popular tourist areas, they add up fast. Some regions have already banned these ingredients to protect their local reefs, so if you're planning a snorkeling trip, consider reef-safe sunscreen. The corals will thank you. Silently so, of course. Fishing practices can also be destructive. Overfishing removes key species that help maintain the balance of the reef ecosystem. Herbivorous fish that keep algae in check, for example. Without them, algae can overgrow and outcompete coral. Worse still are practices like blast fishing, where explosives are used to stun or kill fish. The resulting shockwaves don't just stun fish, they shatter coral structures like porcelain. It's a highly effective way to catch dinner, if you don't mind obliterating the restaurant in the process. Tourism too has its side effects. While reefs draw millions of visitors each year and contribute significantly to coastal economies, unmanaged tourism can cause physical damage. Divers and snorkelers may unintentionally break corals, stir up sediment, or introduce pollutants. Anchors dropped carelessly onto a reef can destroy years of coral growth in seconds. It's a bit like stepping on a cathedral with muddy boots. Possible to repair, but far better to avoid in the first place. Despite all this, reefs are not helpless. They've been through a lot in their evolutionary history. Sea level changes, ice ages, mass extinctions. Corals are resilient in the long term. They can adapt, move, evolve. But the pace of current change is faster than anything they've seen before. Evolution is slow, climate change is not. Still, there's reason to hope some reefs show surprising signs of resilience. Certain coral species are more heat tolerant. Some algae strains recover faster or are more adaptable. In areas where human impact is minimized, protected marine reserves for example, reefs often bounce back more quickly after stress events. Scientists are also exploring innovative solutions like breeding heat-resistant coral strains, cultivating coral nurseries, and even deploying artificial structures to help reefs regrow. There are success stories, small but meaningful. In the Philippines, community-led reef management has restored fish populations and coral health in areas once devastated by overfishing. In Florida, scientists are transplanting lab-grown corals to help repopulate damaged reefs. Around the world, coral gardeners, marine biologists, and local communities are working to give reefs a fighting chance. But these efforts need time, support, and above all, a reduction in the pressures that cause reef decline in the first place. That means tackling climate change, improving water quality, managing fisheries sustainably, and raising awareness. The future of coral reefs isn't just a marine biology issue, it's an everything issue. Food security, coastal protection, biodiversity, even medicine. Reef ecosystems touch all of it. It's easy to think of coral reefs as remote and separate, tucked away in tropical waters most of us will never dive into, but they're part of the same ocean that touches every coast. The same planetary systems, the same air and water we all depend on. What happens to reefs in their quiet, intricate, sunlit worlds ripples outward. So yes, their situation is serious, but not without hope. Corals are quiet, but they're not weak. Given half a chance, they can recover, rebuild, and keep doing what they've done for millions of years, building homes, nurturing life, and turning sunlight and stone into something beautiful. All they need is a little breathing room. It might be easy to think of coral reefs as beautiful but frivolous, nature's underwater art projects, nice to look at but not essential. But nothing could be further from the truth. Coral reefs are not just pretty, they're practical. These vibrant ecosystems perform a staggering number of services for the planet and for people, most of which go completely unnoticed by the average beachgoer. They are unsung heroes, quietly toiling beneath the waves to keep coastlines stable, oceans healthy, economies humming, and even medical labs innovating, all while wearing outfits that would put a peacock to shame. Let's start with one of the most critical and often overlooked services coral reefs provide: coastal protection. Reefs act as natural breakwaters, absorbing and dissipating the energy of waves before they crash onto the shore. That big jagged wall of coral just beneath the surface is taking the brunt of the impact, buffering beaches and coastal towns from storms, erosion, and rising tides. In fact, studies have shown that healthy coral reefs can reduce wave energy by up to 97%. That's like having a free seawall that repairs itself, assuming it's given the chance. In areas where reefs have been damaged or degraded, coastlines are more vulnerable, beaches erode more quickly, storm surges reach farther inland, and infrastructure takes more of a beating. Countries like the Maldives, Fiji, and Indonesia, where entire communities live right at sea level, depend on reefs for their very survival. The irony is that while these reefs protect people from the effects of climate change, they're also some of the first ecosystems to suffer from it. Then there's food. Coral reefs are critical breeding and feeding grounds for thousands of species of fish and other marine animals. Globally, an estimated 1 billion people rely on reef-associated species for their primary source of protein. In many coastal communities, fishing is not just a cultural tradition, it's economic lifeblood. Without healthy reefs, fish stocks plummet. Without fish, people go hungry. Reefs don't just support big-ticket fish like tuna or grouper either. They provide nursery grounds for a vast array of species, offering shelter for juveniles until they're big enough to venture into deeper waters. It's a bit like sending your kids to a safe, well-stocked daycare, only with more tentacles and less snack time. The reef's complexity, its cracks, overhangs and crevices, makes it the perfect place for young fish to hide from predators and grow in relative safety. Economically, coral reefs are gold mines. According to the World Resources Institute, reefs contribute an estimated $375 billion annually to the global economy through fisheries, tourism, and coastal protection. That's a staggering amount, especially considering they occupy less than 1% of the ocean floor. Dive tourism alone, snorkeling, scuba diving, reef excursions, generates billions in revenue each year. And not just for hotels and dive shops, local restaurants, markets, boat operators, artisans, all benefit from reef tourism. It's a complex economy woven through vibrant coral corridors. But reefs offer something else too, something far less visible but just as important. They're a source of medical breakthroughs. Many marine species that live on or near coral reefs produce unique chemical compounds to defend themselves in this highly competitive environment. These compounds have been harnessed for use in pharmaceuticals, everything from antiviral and antibacterial agents to painkillers and anti-cancer drugs. The venom of cone snails, for example, contains powerful compounds that have led to the development of new pain medications. Sea sponges have inspired antiviral treatments, and there's still so much more to discover. Scientists estimate that only a small fraction of reef-dwelling species have been studied for their biochemical properties. Reefs, then, are not just natural wonders, they're natural pharmacies, and losing them means losing the chance to uncover treatments and cures we haven't even imagined yet. Imagine tossing away the world's best medical library before we've finished reading the first chapter. There's also a kind of ecological domino effect at play. Coral reefs don't exist in isolation. They're connected to other ecosystems like mangroves and seagrass beds. These systems work together to filter water, trap sediment, cycle nutrients, and support life. For instance, fish that grow up in mangroves often migrate to reefs as adults, and vice versa. Sea turtles and dugongs feed on seagrass beds but rely on reefs for shelter or cleaning stations. If one part of this network is damaged, the effects ripple outward. weakening the resilience of the entire system. Reefs also play a role in carbon cycling. While they're not as famous as rainforests or peat bogs when it comes to carbon storage, coral reefs still sequester significant amounts of carbon through the formation of calcium carbonate structures. When corals build their skeletons, they effectively lock away carbon in a stable, solid form. Over geological timescales, this has helped regulate the Earth's carbon balance. It's not flashy, but it's important. Just another quiet service offered by a creature that doesn't move. On a more philosophical level, coral reefs remind us of the value of patience and cooperation in nature. They are slow builders, relying on tiny organisms working together over millennia to create structures of astounding beauty and functionality. Each individual polyp contributes just a sliver of the whole, but together they create cities that support the lives of millions. There's something deeply human in that, or at least something we aspire to be, builders of lasting systems, caretakers of complexity, collaborators in something larger than ourselves. And of course there's the joy, the sheer unfiltered joy of knowing places like coral reefs exist. Places where neon-coloured fish flit through underwater canyons, where giant clams glow electric blue, where sea turtles glide like flying carpets. The reef is a reminder that the world can still surprise us, that life can be outrageously inventive and absolutely dazzling even without anyone watching. For many people, coral reefs are their first glimpse into the underwater world. A snorkel trip, a nature documentary, a vivid photo in a science book. All it takes is one moment to spark a lifelong fascination. And maybe that's the most underrated service of all: inspiration. Reefs don't just support ecosystems, they support dreams. They give artists something to paint, writers something to describe, and scientists something to study for a lifetime. So no, coral reefs aren't optional. They're not just aesthetic bonuses or vacation attractions, they're vital, vibrant hubs of life and stability. They feed people, protect homes, fuel economies, heal bodies, and dazzle imaginations. And they do it all without noise, without drama, without complaint. All they ask for in return is a little care, a little space, and a lot less pollution. A fair trade, really, considering everything they give us in return. Of all the coral reefs scattered across the globe, none is quite as famous or as vast as the Great Barrier Reef. Stretching for more than 2,300 kilometres along the northeastern coast of Australia, it's the largest living structure on Earth. Yes, living, not a mountain, not a desert, but a sprawling, pulsing, sun-dappled metropolis built by billions of tiny animals over millions of years. It's so massive that astronauts have spotted it from space, which, let's be honest, is a pretty showy way to get noticed by the neighbours. But the Great Barrier Reef is just one member of a diverse and global coral family. Around the world, reefs take on different shapes, personalities and ecological flavours depending on their location. Some are warm and familiar, others are isolated, remote and still full of mystery. Each one, in its own quiet way, is a marvel of natural engineering. Let's start with the Great Barrier Reef itself. It consists of over 2,000 individual reefs and 900 islands, forming a lattice of habitats that support tens of thousands of species. Sea turtles, reef sharks, clownfish, dugongs, sea snakes, giant clams. It's like someone opened a marine petting zoo and forgot to close the gate. The diversity here is so overwhelming that scientists are still discovering new species every year, hiding among the coral heads or burrowed deep in the sand. The reef is not just a single continuous wall of coral, as some imagine. Rather, it's a mosaic, a scattered, patchy wonderland of reef systems separated by lagoons and channels. It includes fringing reefs close to shore, mid-shelf reefs further out, and outer reefs that drop off into the deep blue abyss of the Coral Sea. Each zone supports its own blend of life, influenced by the water depth, currents, and proximity to land. Historically, the reef has also been important to Indigenous Australian cultures for thousands of years. The Aboriginal and Torres Strait Islander peoples have fished these waters, navigated its channels, and woven stories of the reef into their spiritual and cultural traditions long before satellite images and scuba tanks. For them, the reef is not just an ecosystem, it's an ancestor, a teacher, and a guide. Now, while the Great Barrier Reef tends to steal the spotlight, it's far from the only show in town. Let's head east to the Caribbean. Caribbean reefs are generally smaller and less diverse than their Indo-Pacific cousins, but what they lack in size they make up for in charm. Here, you'll find elkhorn and staghorn corals, species named for their branching shapes resembling antlers reaching toward the surface. These reefs are home to charismatic species like parrotfish, angelfish, moray eels, and those flamboyant feather dusters known as Christmas tree worms. One of the most notable Caribbean reefs is the Mesoamerican Barrier Reef, which stretches from the Yucatan Peninsula in Mexico down through Belize, Guatemala, and Honduras. This reef is the second largest in the world after the Great Barrier Reef, and it supports manatees, whale sharks, and the endangered hawksbill turtle. It also has some of the clearest waters you can imagine, visibility so crisp it feels like swimming in liquid air. The Belize Barrier Reef, a part of this system, was famously visited by Charles Darwin in the 1840s, who called it the most remarkable reef in the West Indies. And it's home to the Great Blue Hole, a massive marine sinkhole that looks like the ocean decided to drop a single perfect polka dot into the middle of the reef. Divers descend into its inky depths past ancient stalactites, relics of a time when the cave was above sea level. It's eerie, beautiful, and deeply humbling. Let's move across the world again to the Red Sea. Tucked between Africa and the Arabian Peninsula, this narrow stretch of water holds some of the most resilient corals on Earth. The Red Sea's reefs thrive in unusually warm and salty water, conditions that would stress or bleach corals elsewhere. Scientists are studying these corals to better understand how some species might adapt to climate change. In other words, if corals were to hold a survival boot camp, the Red Sea varieties would be the tough instructors wearing mirrored sunglasses and barking orders. The Red Sea reefs are also famous for their dramatic underwater topography. Steep drop-offs, coral-encrusted pinnacles, and vertical walls create breathtaking dives. Add to that crystal-clear water and a riot of colourful fish, and you have one of the world's most beloved diving destinations. Countries like Egypt, Sudan, and Saudi Arabia are increasingly investing in reef protection here, recognising that these systems are both ecological treasures and tourism magnets. Farther into the Indian Ocean, you'll find the reefs of the Maldives, coral atolls arranged like a spilled string of pearls across turquoise water. The Maldives may be low-lying, but their reefs are anything but insignificant. These coral systems are vital not just for biodiversity, but for the island's survival. The reefs shield the islands from erosion and storm damage, and they support the livelihoods of thousands through fishing and tourism. Unfortunately, the Maldives have also seen the effects of coral bleaching firsthand. Rising sea temperatures have hit these reefs hard, but local and international conservation groups are experimenting with coral nurseries, heat-resistant coral strains, and reef restoration projects. Some resorts even let visitors adopt a coral or help with planting fragments onto the reef. It's ecotourism with a side of marine gardening. Then there are the Pacific atolls, rings of coral that formed around now-sunken volcanic islands. These atolls, like those in the Marshall Islands, Tuvalu, and Kiribati, are among the most vulnerable places on Earth to sea level rise. Their very existence depends on healthy reefs keeping pace with the rising ocean. If the reefs can't grow fast enough, the islands themselves risk disappearing. It's a stark and poignant example of how coral health is directly tied to human survival, and we can't leave out the reefs of Southeast Asia, the Coral Triangle. This area, which spans Indonesia, the Philippines, Malaysia, Papua New Guinea, Timor-Leste, and the Solomon Islands, is often called the Amazon of the seas because of its extraordinary biodiversity. Here, you'll find more species of coral and reef fish than anywhere else in the world. Think of it as the Earth's original reef headquarters, a swirling soup of life that has nourished civilizations for thousands of years. In Raja Ampat, Indonesia, for instance, a single dive can yield more than 300 species of fish and over 200 species of coral. It's a hotspot within a hotspot. Local communities are deeply involved in protecting these reefs, often through traditional marine protected areas called sasi, where fishing is limited or banned during certain seasons to allow ecosystems to recover. Even cold water corals deserve a mention. Yes, corals exist in the chilly deep oceans too. These species don't rely on sunlight or photosynthetic algae. Instead, they capture plankton, drifting in the dark, slow-moving currents of the deep sea. Some cold-water coral reefs, like those found off the coast of Norway or in the North Atlantic, are centuries or even millennia old. They grow incredibly slowly, mere millimeters per year, but they form intricate structures that provide refuge for deep-sea creatures rarely seen by human eyes. So whether glowing in the shallow sunlit lagoons of the tropics or lurking in the frigid abyss, Coral reefs are everywhere, scattered gems across the world's oceans. Each has its own challenges, its own adaptations, and its own story to tell. And while the Great Barrier Reef may be the most famous of its kind, it's not alone in its beauty or its importance. Every reef, no matter how small or remote, is part of a global network, a living, breathing archive of Earth's evolutionary brilliance. Together they form a kind of underwater chorus, silent to us perhaps, but vibrant all the same. Because in the end, every coral polyp, every branching coral, every fish that darts between the reef's fingers is contributing to something much larger. A planet that works, a planet that glows, a planet that even beneath the waves remembers how to build. Coral reefs shimmer in the sunlit shallows of our oceans, alive with colour and movement, but their story doesn't begin in the present. In fact, corals are some of the oldest builders on the planet, and their history stretches back through vast oceans of time, across ancient seaways, mass extinctions, shifting continents, and the slow, patient churn of evolution. Today's reefs are just the latest act in a saga that began more than 500 million years ago, in a world that would seem alien to us now. To understand corals' quiet genius, we need to trace their lineage through deep time, back to when trilobites scuttled across the seafloor and giant sea scorpions ruled the coastal shallows. The first corals appeared during the Cambrian period, around 535 million years ago. These ancient corals didn't look quite like the ones we see today. They belonged to a group known as rugose and tabulate corals, names that sound more like spell ingredients than animals. They were solitary or colonial creatures, often forming horn-like shapes or honeycomb patterns. Unlike modern reef builders, these early corals were made from calcite rather than the aragonite used by modern scleractinian corals. That's a detail only a geologist could love, but it tells us something important. Corals have reinvented themselves over time, adapting not just to changing ecosystems, but to the very chemistry of Earth's oceans. During the Ordovician and Silurian periods, roughly 485 to 420 million years ago, these ancient corals formed small reef-like structures, often in partnership with stromatoporoids, sponge-like creatures that also secreted calcium carbonate. Together, they began building some of Earth's earliest reef systems. It was a slow revolution, a silent spread of structure across shallow continental shelves, providing homes for marine life and creating the blueprints for the complex ecosystems that would follow. Fast forward to the Devonian period, often called the Age of Fishes, and coral reefs were thriving. This was a golden age for early reefs, with massive build-ups stretching for miles. The corals and stromatoporoids built vast underwater structures, and for a time life flourished. Then came one of Earth's great extinction events. Roughly 370 million years ago, the late Devonian extinction swept through the oceans, wiping out many coral groups and setting back reef building for tens of millions of years. For a while, coral reefs all but disappeared, but extinction, as it often does, cleared the way for something new. After a long pause in reef construction, a new group of corals emerged during the Triassic period, around 240 million years ago, the scleractinians. These are the ancestors of most modern reef-building corals. Unlike their ancient predecessors, scleractinians formed partnerships with the photosynthetic algae, early versions of the same zooxanthellae that power reefs today. This was a game-changer. With energy from the sun, these new corals could grow faster and build more complex structures than ever before. And so, in the warm, shallow seas of the Mesozoic era, coral reefs made their triumphant return. They flourished alongside the dinosaurs, waving gently in the currents while massive marine reptiles hunted nearby. The reefs of this time looked familiar, branching, domed, alive with life. But many of the species were entirely different. Nature was running its great experiment again, testing forms and functions, selecting for resilience and cooperation. Then once again, catastrophe. Around 66 million years ago, a massive asteroid impact marked the end of the Cretaceous period and wiped out roughly 75% of all life on Earth, including the dinosaurs and many marine species. But the coral reefs, they were bruised, yes, but not broken. They survived. In the Paleogene period that followed, they began to rebuild, slowly but surely, adapting to a new Earth with new ocean currents, new climates, and new cast members in the marine drama. Over the last 50 million years, modern coral reefs have spread and evolved into the forms we see today. The rise of coral atolls, circular reefs that form around sinking volcanic islands, was described in poetic detail by Charles Darwin during his voyage on the HMS Beagle. He correctly hypothesized that as volcanic islands subsided, the fringing coral reefs surrounding them continued to grow upward, eventually forming ring-shaped structures with a central lagoon. It was one of the earliest and most elegant explanations of biological geology. But the story of coral evolution isn't just about survival, it's about persistence. Through 5 mass extinctions, shifting continents, ice ages, and warming seas, corals have endured. They have changed their partners, from calcite to aragonite, reshaped their communities and rebuilt their cities from scratch. That's not just resilience, it's adaptability on a planetary scale. Fossil reefs found in places far from today's oceans are vivid reminders of Earth's changing face. In the middle of deserts or atop mountain ranges, paleontologists have uncovered ancient coral skeletons preserved in stone. These are echoes of long-gone seas, locked in limestone, where coral reefs once flourished beneath the waves. Imagine coral heads now high in the Himalayas, silent witnesses to the rise of continents and the relentless push of tectonic plates. The Earth moves slowly, but it moves. These fossil reefs also help scientists understand how coral ecosystems responded to past changes in climate and ocean chemistry. For instance, during periods when the planet was warmer than it is today, like the Eocene or the mid-Miocene, corals expanded their ranges, sometimes growing much closer to the poles than they do now. During colder periods, reefs contracted. By studying these ancient records, we gain clues about how modern reefs might respond to the warming oceans of the future. But there's a catch. In the past, environmental changes unfolded over thousands or even millions of years, giving coral species time to adapt, migrate, or evolve. Today, the changes are happening on human timescales, decades, not millennia. That's fast, uncomfortably fast. The question isn't whether corals can adapt, it's whether we're giving them the time and space they need to do so. Still, there are glimmers of hope. Some modern corals are already showing signs of adaptation, hosting more heat-tolerant algae, adjusting their growth patterns, even shifting their spawning times. In essence, they're doing what they've always done, adjusting to a new normal, quietly and steadily. It may not be flashy, but it is remarkable. Corals, it turns out, are long-distance runners in the race of life. They don't sprint, they don't shout, they don't demand our attention, but they endure, and that endurance is written into the very bones of the Earth. Through fossils and stone, ancient reefs whisper stories of a world constantly in motion, constantly being rebuilt. Perhaps that's the real genius of coral. Not just their beauty or their complexity, or even their role in supporting life today, but their perspective. They've seen the Earth change, survive, and start over. They've been the backdrop to evolutionary drama and the foundation for marine empires, and they've done it all with quiet tenacity. When we look at a reef today, we're not just seeing a living ecosystem, we're seeing history in motion, a lineage that began 500 million years ago and continues to this day, one polyp at a time, a story not written in ink but in calcium carbonate, sunlight and silence. And perhaps, as we face our own challenges, there's comfort in knowing that something so ancient, so patient and so quietly clever is still here, still building, still believing in the long game. Human beings have always been drawn to coral reefs. Long before scientists donned their dive masks or tourists strapped on snorkels, people living along tropical coasts knew the reefs well. They fished among them, respected their rhythms, passed down knowledge of their bounty and dangers, and wove them into stories, songs, and sacred traditions. For thousands of years, reefs have not only fed and protected human communities, they've inspired them. But like so many relationships between people and nature, the one between humans and reefs is a complicated dance of care, neglect, rediscovery, and, in more recent times, urgent repair. In many coastal cultures, coral reefs were never seen as something separate from society. For the Polynesians, reefs were part of the living seascape, a realm full of spirits, lessons, and navigational cues. In the Philippines, traditional marine sanctuaries called pamana, or Bantay Dagat, sea guardians, were protected by communities long before government conservation programs existed. In parts of Papua New Guinea and the Solomon Islands, reef fishing was, and still is, guided by customs that restrict harvest during spawning periods, ensuring the reef can replenish itself. These ancient systems weren't based on formal science, but they often aligned with ecological principles. Elders knew, for instance, that overfishing a reef during breeding season led to lean years ahead. They understood which species were seasonal visitors and which were permanent residents. They didn't need spreadsheets. They had memory, observation, and stories. In many cases, the reef was treated not as a resource to exploit, but as a relative to respect. Then came a different kind of relationship, one driven by extraction, commerce, and technology. Over the last few centuries, the pace and scale of human activity around reefs have increased dramatically. Dynamite fishing, cyanide fishing, dredging, and unsustainable tourism have left scars on reef systems across the world. Fishing boats, no longer powered by wind or paddles, can now reach once remote reefs with ease. Pollution from distant cities finds its way into reef waters through rivers and runoff. Reefs that once thrived with quiet resilience are now under nearly constant pressure from the surface. The rise of global tourism has been a double-edged sword. On one hand, it's brought millions of people face to face with the wonder of coral reefs, people who might never have known such beauty existed beneath the waves. Many leave inspired, humbled, and newly invested in conservation. On the other hand, unmanaged tourism has caused significant damage. Divers and snorkelers, though well-meaning, can accidentally break coral by standing or grabbing onto it. Anchors dropped from tour boats can crush years of coral growth in a single moment. Sunscreens containing harmful chemicals leach into the water, stressing coral polyps already struggling with rising temperatures. But not all tourism is bad for reefs. In fact, it can be part of the solution when it is done right. Many coastal communities have begun to shift toward ecotourism, where protecting the reef isn't just an ethical choice, it's good business. Dive resorts now teach reef etiquette. Visitors are encouraged to use reef-safe sunscreen, avoid touching marine life, and support conservation programs through fees and donations. Some resorts and marine parks even invite guests to participate in reef restoration. Planting coral fragments or cleaning up marine debris is like reef rehab with flippers. Fishing too is being reimagined. In many parts of the world, community-managed marine protected areas, MPAs, are helping fish stocks rebound and reefs recover. These are zones where fishing is limited or prohibited, giving marine life a chance to regenerate. Studies show that well-managed MPAs often lead to an increase in fish populations, not just within the reserve, but in surrounding areas too. As fish spill over into neighbouring waters, it's a win-win. Conservation meets food security. In the Seychelles, for example, local fishers have helped establish protected zones and seasonal closures to safeguard spawning fish. In Indonesia, some villages have revived traditional reef management practices, combining ancestral wisdom with modern science. These efforts aren't just preserving reefs, they're strengthening communities, restoring pride, and giving people a stake in the health of their marine environment. Meanwhile, on the scientific front, reef restoration is taking off in ambitious new ways. Coral gardening, once a fringe idea, is now practiced in dozens of countries. The process involves collecting small coral fragments, often broken by storms or boat traffic, and growing them in underwater nurseries. These corals are then transplanted back onto damaged reefs, where they can regrow and help jumpstart recovery. In the Caribbean, staghorn and elkhorn corals, both critically endangered, are being grown by hand in underwater coral farms, suspended from ropes and PVC frames. Volunteers and marine biologists tend to them like underwater bonsai, pruning and transplanting them onto reefs with surgical precision. It's slow work, but it's yielding promising results. Elsewhere, scientists are experimenting with selective breeding and assisted evolution. By identifying corals that are more resistant to heat or disease, researchers hope to breed hardier strains that can withstand the warmer, more acidic oceans of the future. Some are even exploring the idea of supercorals, genetically robust individuals that could be planted in vulnerable areas to give reefs a fighting chance. Technology too is lending a hand. Artificial reefs made from concrete, ceramic, and even 3D printed materials are being deployed in areas where natural reef structures have been lost. These artificial substrates provide a place for coral larvae to settle and for fish to find shelter. While they're not a replacement for living reefs, they can serve as a temporary lifeboat, giving nature a foothold while the ecosystem rebuilds. And then there's the power of storytelling. Documentary films, underwater photography, virtual reality experiences, they're all helping bring the reef to people who might never dive below the surface. Awareness campaigns are changing consumer habits, encouraging sustainable seafood choices, reef-friendly sunscreen, and responsible travel. Even art is getting involved. Sculptors have created underwater galleries that double as artificial reefs, blending conservation with creativity. Still, the future of reefs depends not just on scientists, divers, or coastal communities, but on all of us. Because the greatest threat to coral reefs remains climate change. And climate change is not a local issue, it's global. The most beautifully managed reef in the world cannot survive in an ocean that grows too hot, too acidic, or too storm-ravaged. Protecting reefs means reducing emissions, rethinking energy, and choosing long-term planetary health over short-term convenience. Yet there's something undeniably hopeful in the way people are rallying for reefs. Across continents and cultures, the reef has become a symbol of what's at stake and what's worth saving. It's a reminder that we're not separate from nature but part of it, that our survival is linked to that of tiny coral polyps, glowing quietly under the sea. So perhaps the relationship isn't so complicated after all, it's just evolving, from dependency to destruction, and now, hopefully, to partnership. We're not just visitors to the reef anymore, we're caretakers, collaborators, and, if we're wise, humble students. And if we listen closely, maybe we'll hear what the reef has been trying to teach us all along. That strength doesn't have to shout, that beauty can be functional, and that even the smallest actions, when multiplied over time, can build something vast and enduring. And so we return to the quiet heart of the coral reef, the patient, glowing metropolis beneath the waves. We've travelled through its biology, its architecture, its drama, its fragility, its ancient history, and its entangled relationship with us. And perhaps now, as you lie there with your eyes soft and your thoughts drifting, you can appreciate the reef not just as a place, but as a presence, a slow-moving miracle humming gently just below the surface of our blue planet. The coral reef doesn't demand attention, it doesn't rush, it simply builds, quietly, collaboratively, beautifully. It teaches us that great things can come from small actions repeated with care, that community matters, that balance is everything, and that in a world often obsessed with speed, there is still immense power in going slowly. If the reef has taught us anything tonight, maybe it's this, that even the stillest things can shape the world. Now, if you've made it all the way to the end of this video, you deserve a round of applause, or at the very least, a very restful night.
And now, we rise slowly back toward the surface, leaving behind the living cathedral of the reef. The colors fade into blue, the sounds soften, and yet the memory of that world lingers, an endless city built quietly, patiently beneath the waves. It's humbling to think of the tiny coral polyps still at work below, layering stone upon stone, turning the invisible into the immense. No rush, no noise, no spectacle, just persistence. They remind us that some of the greatest achievements in nature are not fast or loud, but steady, delicate, and almost invisible. Drifting upward, you might picture the schools of fish weaving through coral branches, the sea turtles pausing to rest in their shelter, the endless cycle of life flowing in and out of this hidden metropolis. The reef doesn't ask for recognition, it simply exists, enduring, shaping, nurturing, all in silence. Perhaps that's the lesson it leaves with us tonight. That genius can be quiet, that strength can be patient, that the most fragile things can also be the most vital. As the last traces of the reef disappear into the depths below, carry with you its calm persistence. Let it soothe your thoughts, soften your breathing, and remind you that life doesn't always need to hurry. Sometimes the most profound changes come in whispers, not in shouts. If you're still awake, I'd love to know what part of the reef captures your imagination most. Share your thoughts in the comments. And if you found this journey calming, liking and subscribing to Sleep Theory helps this sleepy little corner of the internet grow gently, one quiet night at a time. Until we drift together again, may your sleep be steady, your dreams as colorful as coral gardens, and your rest as deep as the ocean itself. Good night.